Hi, my name is H Kenyon. I'm 70 years old. I'm an independent researcher. The purpose of this recording is to offer you a understanding of where gravity comes from, what it is and where it comes from. Now, in order to do my research, I use two modalities. One is logic, the other is alternate point of view. Now, logic would be, well, there's water on the back of my hands. Where did it come from? It's not raining, I didn't put water on it. I wasn't doing work, it's a little hot. So the water must have come up through my skin. Therefore, skin has holes in it. That's logic. The other way I do my research is alternate point of view. Now, I'm going to say that three guys want to go fishing for the weekend. So they call ahead and they reserve some cabins. But when they get there, it's raining, and it's going to be raining all weekend. So they said, well, let's just play cards. We're here, we'll play cards. So when they check in, they say, well, we only need one cabin. And the kid at the desk says, well, you reserved 3 cabins. I said, no problem, it's $10 a piece. We'll, and they paid them $30. Okay? So a little time comes by, and the owner of the place comes back and says, did the guys check in to the cabins? He says, yeah, but they only took one cabin because it's raining, they can't go fishing, they're gonna play cards all weekend. And he says, so how much did you charge? He says, well, $30. He says, oh no, they're gonna think we overcharge them. Here's $5. Take it back to them and tell them the management's sorry, we made a mistake, and we feel that we've overcharged you, so here's $5 back. So the kid takes the $5, goes to the cabin, knocks on the door and says, management thinks we've overcharged you, we're giving you back $5. And the guy says, well, how's 3 of us going to split up $5? He says, look, we'll take $1 a piece. Here's a $2 tip for doing it, and everything's fine. So, originally they paid $10 a piece for the room, they got $1 back. So now they only pay $9 for the room. 9 3 is 27. The kid got a $2 tip. Okay, so that's 29. Where's all the money? Now, the point of this is from the point of view of the people running the place. They had 30, he gave away 5, he's got $25, he can say where's all the money. The kid that ran back and forth with the money, he knows that he knows it was $30 to start, $5 came away, 3 went in the room, 2 went in his pocket. He can say where is all the money. But from the point of view of the guys in the room, they can't properly ask the question or get the right answer. Where's all the money? Now, I'm going to give you 3 steps to explain gravity where it comes from. This is a regular bathroom scale, okay? No big deal, spring loaded. So when we step on a scale, and you look at it, you get a reading. This is 163, okay? However, when I do this, it's 161 and a half. I lost a pound and a half. How can that be? But that's what happens. Also, if you use digital, you find out it doesn't work very well. Lots of digitals only record the first weight and no changes, or it reads error. So that's the first thing. The second thing is we're going to talk about specific gravity. This is a bowl of water, and if we put something in the bowl and it's filled right to the brim, some of the water wants to come out. That's not a big deal. Now here's the same size ball, but it's full of water. A lot more water comes out. That's specific gravity. Everybody knows that. Long and the short is water doesn't like to be compressed. so it'll actually move out of the area so that it doesn't get compressed. So the third part of this is, let's talk about open space, okay? And for our example, we're going to talk about 1 cubic mile of open space. And for the point of this example, let's say there's 9 particles in this cubic mile of open space, which means that the cubic mile above it also has 9 particles per cubic mile, the one behind it, the one next to it. All around this, all the square miles have 9 particles per cubic mile. And they all want to keep their own spacing. All right? Now, into this area, we interject a planet, let's say Earth, 4,000 miles across, 127,000 miles around, but we now push this Earth into this space. Well, the space is going to move out of the way. Okay? The 9 particles, they're trying to all maintain the spacing, so they push back against space, and those particles are pushing on the Earth. Now we have an atmosphere around this planet, hydrogen, oxygen, nitrogen, and so on, a lot of other chemicals. And at the surface of the planet, it's 14 miles per square inch. However, if we go up on a mountain, it's not 14, it's a lot less. In fact, we have mountains on the Earth that are so tall that when you get up there, you got to use oxygen because the air is so thin. So what I'm saying is space is pushing on the atmosphere is pushing on us. Okay? It's less dense high up, it's more dense closer in. So gravity is a result of space pushing on the Earth. Okay? Now, everything has a resonant frequency. Space has a resonant frequency, the Earth, everything in this room, this building, we all have different specific gravities. Resonant frequencies. And, for example, if a sound is coming towards you and you don't like that sound, if you make a recording of that sound and send it right back to where it's coming, they neutralize each other. All right? Now this is, I'm sure you recognize it, it's, a magic ear. And this is amplifier. And all I did was this, it makes a 10-second recording. I aimed it up and made a 10-second recording at night. And so now I'm taking the signal, I'm sending it through an amplifier into this speaker on the scale. Now I added this dome to it because I think sonics are involved and I wanted that. So I'm going to play it now. See, it loses. As long as it's playing, it loses. Now it goes back the way it was. Not a lot, but we're taking the frequency, the resonant frequency, and that's coming down, and I'm pushing it right back up, and therefore this loses weight. So in my research, I'm going to be doing other recordings using other frequencies. Personally, I think that 3 speakers with different frequencies coming out, they will spiral and give me more push. Theory at this point, but that's the purpose of this recording, is so that you will understand if you choose. So where are you now? Are you in the cabins, on the Earth, unable to make a good decision because you're involved in the gravity? Or are you in the building in space and realizing that space is pushing on our atmosphere is pushing on us? Now, the other thing I just want to wind up with is when I stepped on the scale, I lost 1.5 pounds. Why did that happen? When I stood, the atmosphere is pushing all over my body, okay? But when I tuck myself up into a tight ball, the backs of my legs are not exposed. My tops of my leg is not exposed. My stomach is on it. My stomach is not exposed. Inside of my arms are not exposed. So when I tuck myself into a ball, I'm reducing my surface area that the atmosphere can push on. And in this case, I lost 1.5 pounds. I've been told that on 2-story buildings that have a flat roof, people are losing 2 and 3 pounds. Okay, it depends on where you are, how much you lose. So that's my explanation. Thank you much for your attention. Have a great day.